quadratic function when you have a reflection over x and a reflection over y? Sorry, wrong way. I'm zooming in because this is kind of hard to see. Alright, so for the reflection over the y-axis, the x values are what change. Do you guys remember how they change? Yeah, they become the opposite. So the x values, which is the input, okay, they become the opposite. Okay, and then the x values, if they become opposite, what we're going to do is see what happens when we plug this into the parent function. Okay, so remember that the parent function is f of x equals x squared. So that's where we're going to plug that in. Now, the rule is f of negative x. Remember we talked about how we could remember where the negative went, and it was y. That rhymes with I, so it goes inside. And if I plug this into my function, what I'm going to do is I'm going to replace x with negative x. And now I'm going to simplify. So negative x raised to the second power, that's just negative x times negative x. And when I multiply a negative by a negative, what do I get? A positive. So this is going to be x squared. See how that's the same as the parent function? Yeah, so when I graph this, it is going to be the same. Okay, so graph is the same as the parent. And we're going to look at this so we can understand why that happens. So remember, this is a reflection over the y-axis. So if I reflect the left side of the graph over y, it becomes the right side, and then vice versa. So because this is symmetric about the y-axis, okay, the reflection actually overlaps the original. So on the graph, they look the same. Okay, so now let's think about what happens with the x-axis. Okay, so the reflection over the x-axis means that the y values become the opposite. The y values are the output. And they become opposite. So remember that our rule for x means the negative is on the outside. Looks like this, negative f of x. So when we apply that to x squared, it becomes negative x squared. So when you're graphing, this becomes a parabola that opens downward, which makes sense when we investigate the reflection. Okay, so this is a reflection over the x-axis. Here's my original parabola. And then if it reflects over x, Okay, now we're going to look at the horizontal stretch and compression. Remember that the rule stays the same for both the stretch and compression. The only difference is what the value is. So if it's horizontal, it's a stretch if the absolute value of the factor b is greater than 1. It's a compression if the absolute value of b is between 0 and 1. So that's the absolute value symbol. And then same thing with vertical, except we use A. So if the absolute value of A is greater than 1, it's a stretch. If the absolute value of A is between 0 and 1, it's a compression. But the rule is the same. Okay, it stays the same for horizontal, it stays the same for vertical. So when it is horizontal, it is the x values that change, okay, or the input. And what they change by depends on the factor. Okay, this is an area that some people didn't get right on the quiz. Okay, so you have, if it's horizontal, it's the x values that are going to have the change applied to it. The horizontal rule is f of 1 over bx. And we talked about this. The 1 over b represents what? Yeah, the reciprocal of what? B. Okay, so 1 over b is the reciprocal of your factor b. Okay, and whether it's a stretch or compression, that's being applied. Alright, now when you have this in a quadratic function, we're going to remember one of our rules of exponents, which is that if you have 1 over b of x, if you plug that into your parent function, this becomes 1 over b x, that quantity squared. And then you have to apply the square to both the number and the variable. So if you apply 1 over b to the power of 2, what's 1 squared? Just 1, because it's 1 times 1. B squared, we're just going to leave it like that because we don't know what the number is. But then you also have to apply it to x. Okay, so we're going to be working with some of those properties in this section. Okay, for your vertical stretch or compression, it is the y values. Okay, so for vertical, it's the y values, or the output that changes. So remember for that, it's a times f of x. That's our rule. Well, remember, f of x is just x squared, so this is just a times x squared, or ax squared. Okay, so those would be the same thing. Okay, so for example 3, we're still using our parent function. We're still using, sometimes it'll say f of x equals, sometimes it might say y equals x squared. It's the same thing. Okay, and then we do have to describe the transformations and then graph each function. So describe the transformations, graph each function. And for part A, we have g of x equals negative 1/4 x squared. Okay, as we become better at this, well, some of you might be able to do it now. You can use your function to describe the transformations. We are going to graph it first. So let's find our vertex. So step 1, find your vertex. This is not in vertex form, so we have to use x equals the opposite of b over 2a. So I want you to do that step where you're finding the x. To think about what your b is, what your a is. Okay, when is your b value 0? When there's no what? There's no what? Okay, but what would tell you that? How would you know when there's no b? Yeah, you wouldn't see an x value, right? So here we just have x squared. So our a value is negative 1/4. You would have to take the negative with that. Again, for this one, your b is 0, so it's not going to affect it. But your x value would be 0 over 2 times negative 1/4, which would simplify to 0. Okay, now your y value, you are going to plug in x into this equation. So your y, finding the y, is just like doing g of 0. So negative 1/4 times 0 squared is going to be 0. Okay, so your vertex is going to be 0, 0. That means that there's no what? What's not happening here that was happening in the other ones? Yeah, there's no translation, right? The graph's not moving left or right or up or down. So now we can do our table. Okay, so with the table, we are always going to put our vertex in the center. So 0, 0. I box 9 in and label it. And then I just go 2 up, 2 down. Okay, so this would be 1, 2, negative 1, negative 2. And then if I can avoid plugging in the negatives, I will. So I'll just start with 1. So this is negative 1/4 times 1 squared, which will give me negative 1/4. Negative 1/4 times 2 squared. So I'm just plugging those into my equation. 2 squared is 4. What's negative 1/4 times 4? Negative 1, right? Because negative 1/4 times 4, the 4's will cancel out. And we can do the same thing with these. Negative 2 squared, that's going to be 4. So negative 1/4 times 4, yep, that's negative 1. If I change this to a negative 1, negative 1 squared is still 1, so this would be negative 1/4. Okay, and then sometimes when you're constructing the graph, you might want more points so that you get a good picture. So when I do this, I get 0, 0. I have negative 1, 1/4, positive 1, negative 1/4, 2, negative 1, but then I still have like all this graph, so I want to know what's happening. So I might plug in an extra value. I might see what's happening at 3. Okay, so if you do negative 1/4 times 3 squared, it'd be negative 9/4. How many times does 4 go into 9? Twice. And how many left over? Yeah, so it'll be negative 2 1/4. So that's going to help me when I graph. And then I know that this is symmetric, right? So that's just going to give me a better picture. Okay, that's your g of x. Okay, f of x is still 0, 0, 1, 1, 2, 4. I put that at 3, so that was, nope. Okay, so one thing I can tell from the graph is that there was a what? Reflection. I could also tell that from the equation because I have the negative out front. Okay, so there is a reflection across what? Good. Reflection across the x-axis. You do have to say if it's x or y. and again, you can use the rule or you can use your graph. So if I look at the parent function, all of these stay the same as my parent. But all of my other values were multiplied by what? Good. So the y values multiplied by negative 1/4. Now, we know that the negative is going to be with the reflection. So this is just going to be a vertical compression. Why compression? Because between 1 and 0. Absolute values between 1 and 0. So by a factor of 1/4. And again, you use the absolute value because the negative goes to the reflection. All right, you guys can start the homework tonight if you don't want to have a bunch of it tomorrow. And then we'll finish the notes tomorrow, and I will check the homework on a Wednesday.